Okay, so this is where we're going to do the math part of the problem number 3. All right, so we know that we have 5 grams of potassium carbonate. So like I said, always start with what you know. So we know 5 grams of potassium carbonate. Remember, that's K2CO3. So that's how you start your equation. All right, and then again, remember, what else do we know? Like, where do we go from here? Well, we know that we need to cancel out grams of potassium carbonate because we want to end with grams of carbon dioxide, because it's asking for of the gas, and we know that the carbon dioxide is the gas. So we have to get from grams of potassium carbonate to grams of carbon dioxide. All right, so again, I always say start with what you know. We know that we have 5 grams of potassium carbonate. To move forward from there, what else do we know has grams in relation to potassium carbonate? The molecular mass. We know that so many grams, when we add all the atomic masses together, that equals 1 mole of that compound. So let's figure out what the molecular mass is of potassium carbonate. And then we also know that we put the grams on the bottom so that those can cancel out. So let's see here. Grams, potassium carbonate on the bottom. And then we put the 1 mole of potassium carbonate on the top. Alright, so let me pull out my handy dandy periodic chart here. So we know that potassium is 39.10. We have that times 2 because we know that from the chemical equation that potassium carbonate, it has K2CO3. So we have 2 potassiums, we have 1 carbon. We know that carbon is 12.01 from looking at our periodic chart. Oxygen, there are 3 of those. Oxygen is 16, so that's going to be times 3. All right, so let's add all those together. So we have 16 times 3. That is going to be 48. 39 times 2 is 78.20. Alright, so 78.20 plus 1 carbon, which is 12.01, plus the 3 oxygens, which is 48. And then we get, so the molecular mass for 1 mole of potassium carbonate is 138.21. Again, I just added all those together. I really need to work on my writing. That does say 138.21, I promise. Maybe by the end of these I'll do a little better on these videos. Okay, so now we've gotten rid of the grams of potassium carbonate. How do we get rid of the moles of potassium carbonate? Well, we look back at our equation and we know that we have 1 mole of potassium carbonate in our equation. So that will be our way of canceling out this one. So now if this was equation and it had been 2 moles, we would put 2 moles down here. So it's the number of moles or number of that compound that you have that goes down here, because that's the ratio in the problem. All right, so we're going to write draw another line, and we're going to write 1 mole of potassium carbonate on the bottom. That cancels out that subscript. And then what goes on top, you ask? That is the compound or element in the equation that we are trying to produce, which in this case, what we're looking for is grams of the gas. We know that carbon dioxide is going to be the gas. You know, it's like oxygen, because some of these ions will decompose into oxygen rather than carbon because it doesn't have carbon in it, but that's a whole nother story. So we know that the gas is carbon dioxide. So how many moles of carbon dioxide do we have in this equation? And we have just 1 based on our balanced equation. So on top here, to show the ratio in the equation, we're going to put 1 mole of carbon dioxide. All right. And then again, what do we know that is related to moles to get us to grams? Because we need to get from 1 mole of carbon dioxide to grams of carbon dioxide. Again, we know that the molecular mass is in grams, so we need to calculate what the molecular mass is for 1 mole of carbon dioxide. All right, from earlier we know that carbon has 12.01, so 12.01 plus, we have 2 oxygens this time, so plus 16 plus 16. So we know that the molecular mass, you probably can't even see that, molecular mass for carbon dioxide is going to be 44.01. 44.01 grams. All right, so our moles cross out. And so we've finally gotten to what we are looking for. And so we can stop there because we're looking for grams of the gas, which is the carbon dioxide. So now we're going to multiply across the top, multiply across the bottom, and then divide the top by the bottom. So I'm going to thank Dominic for the courtesy of using his tablet for my calculations here. 5 times, so that's just 1, so 5 times 44.01. So top we have 220.05. The bottom, we just have 138.21, 220.05 divided by 138.21. That gives us 1.59. Well, it's like 1.592, but we'll just do 1.59, and that is grams of carbon dioxide. And I think that this is the sheet where if it's a product, you have to multiply it by the percent yield, which I think is like 93%. So carbon dioxide is a product, so we're going to multiply that 1.59 times 93%, which I multiplied it by 1.93, and so the answer is going to be 1.4787. I don't know how far he has you write it out, but so that is my, see if I can hold it straight so that so that is my, after I multiplied this by 93%, because it's a product. And so we get 1.4787.